Okay. Alright. Okay. So for today's class, we will move to the lecture 5. Yes, signal conditioning amplifier. So for the test one, it will be covered until this topic. Okay. So let's move. Uh, last week, we have learned about inverting configuration. Okay. So you have learned this one during your just during your second years, and then okay, and also your electrical lab, I think. So last week what we learned about inverting. Inverting, that's mean uh this is the circuit for inverting. Okay, so you have 1 and 2. Okay, the feedback resistor. So this one R2, this one R1, this one V in, and the other one is V out. Alright, so this is the inverting circuit. So now you got it is gain here. So I call it is G is equal to minus R2 over R1 here. And then because of the inverting, right, mean it invert the uh, the value of the inputs here, right? And then you will got it is negative 1. And then you need another inverting in order to get a positive output here. Okay, so the value, maybe you can choose 1k and 1k here. It must be the same value here, and then this one will be your final output, the out. Okay, and in order to change the gain, right, in order to change the gain value, you can play around with this value R2 and R1. So this is the inverting. And number 2, we have learned about non-inverting. Okay, non-inverting, the same circuit with this one, but you just switch ground and also be in here. Okay, so it will be minus and plus. So this one be in, and this one the feedback resistor maintain, and also input will short at the ground. So this one R1 and also R2 be out and also be in. Okay, wait a minute. Right. Now the gain you get it is here is equal to 1 plus R2 divided with R1. Okay, so the good thing about non-inverting is you got it is positive output here. Okay, but the bad thing about non-inverting is it cannot be used as the attenuation. Okay, right? It cannot be used as the attenuation. Why? Because this one 1 plus R2 over R1. Okay, but it can use for amplifier. That's mean from the smaller voltage become the larger voltage. Yeah, it can be used. And the gain one, you can adjust R2 and R1 here. Okay. All right. So this is what we have learned on last week. Do you have any question or you want to ask? So you can raise your hand and also you can type in the chat. Okay, for today we will learn about another configuration, which is voltage follower. Okay, I'm not cover on this topic on this topic yet, right? In this topic I'm not cover yet, right? Is it? Betul kan? Saya tak cover topik ni lagi kan? Not cover yet. Okay, good. Because I'm quite confused with another section, right? Because every Tuesday I got a meeting, I got something else to do. Okay. Anyway, this one is voltage follower. Okay. So for the voltage follower, minus and positive here. So this is the output. Okay. and this is the input. So V in here and V out here. Is it right? Okay. So why you need a voltage follower is sometimes your transducer, right? So for example, it detect temperature and then the maybe the voltage it will be microvolt, for example. Okay. So okay, sorry. Maybe the voltage will be millivolt, but the current may be microamp. So the current is too small, right? So when you try to put it into a load, right? For example, your motor, right? So this motor is not enough to drive. That means this current is not enough to drive the motor, right? So what you need to do is instead you connected directly to this one, right? Then you connected to be in here, right? So this one what I mean that's mean I already explained during your lab one, right? Okay. So then you can connect your motor at here. Okay. So when you connect like you have the voltage follower here, right? That's mean you can drive this motor. Okay. So that's why we use the voltage follower. So sometimes we call it is the unity gain input. Okay. All right. So next one is the summing circuit. So the voltage follower before that is the gain is equal to 1. Okay, there is no gain, right? So we can say that the gain equal to 1. Next one is the summing circuit. Summing, alright, summing amplifier. Okay, so the summing amplifier, that's mean all is from inverting amplifier. So you just draw the inverting first. Then this is the input. This is what let's say I put it is RF. Okay, this one R1. This one the V1, and also this one is the V out. Okay, right. This is the inverting amplifier. So how to draw the summing? Summing, that means you have another input. Let's say this one is V2 and this one R2. And you can have another input. Okay, let's say is V3 and this one is R3. Okay, that is the summing. If we try to sum all of the input V1, V2, and also V3. Okay, let me ask you something. Can you give me an example where is the summing circuit is applied? Okay, where is the summing circuit is applied? Okay, where is it? Where is the summing circuit is applied? Everybody? Uh, anyone that you want to answer? Calculator. Okay. What? What is calculator? Okay. Another one. Where is the summing circuit is applied? Kat mana ni applied? Okay. Anyone? Come on. Give me some feedback. Aini Fazlini. Okay. Shamila. Shamila, are you guys or girls? Meter box. Meter box. Audio mixer. Yes, you are right, Muhammad Akid. Okay. So, let's say you go to karaoke, right? Karaoke. So you go with your friend. Then your friend take mic 1. Okay. And the other one take a mic 2. Or maybe you have another friend, mic 3. Okay. Or maybe this one is the worker there. Okay. Mic 1, mic 2, and mic 3. And then it will amplify, right? Okay. Something and so on. So maybe this one you can put to your speaker. Okay. How to draw the speaker? Yep. This one is your speaker. Okay. So it's try to what we call it to summing or this one, right? So that you can heard your sound voice at the speaker on. So this is the one application lah, right, for the summing circuit. Okay, so how about the equation here, right? Because this summing circuit is used it used like what we call it like says the inverting circuit, right? So of course the output you will get here is negative, right? And then in order to get another in order to get a positive output, you need to have another inverting. Okay, so the formula for this V out here is, if you can see there, so I just take it V out equal to minus G1 V1 plus G2 V2 plus G3 V3 plus and so on. Okay, so this is the formula for this one. Okay, alright, and then I just take it minus V out equal to G1 V1 plus G2 V2 plus G3 V3. In this case, we have a 3 input, so until G3. Okay, alright. So what is the G1? The gain number one is RF over R1. The gain number two is G2 equal to RF over R2. And the gain number three is equal to G3 is RF over R3. Okay, so that's mean sometime maybe your mic got some problem about at the output and so on. So maybe in terms of this gain, right? So we can adjust this one. Okay, so G1, G2, and G3. So this is the formula. So that's mean in this summing, it have gain G1 and it have the gain G2 and it also have gain G3. Okay, right. Okay, so let's go to this example 5.3. Okay, now you got it. Is this equation. Develop an OM circuit that can provide an output voltage related to the input voltage by V out. V out here is equal to 3.4 V in plus 5. Okay, so when you look at here is 3.4 B in plus 5. That means this one is have the two input right here. One is this one, another one is this one. Okay, so that means is you need to use okay, you have learned inverting, you have learned non-inverting, you have learned voltage follower, but all that one is only require one input. Then for the more than one input, that means you need summing circuit. Okay, so what you need to do is you just compare with the equation that I have shown it to you. Okay, minus V out is equal to G1 V1 plus G2 V2. Okay, so I just take it minus V out, right? So that you will not do some mistake here. So then now you can compare which one that you want. All right, so let's say I take it G1 here is equal to 3.4. Okay, and V1 here equal to V in. All right, and G2 here I take it 1, right, because 5 times 1 here, and V2 is equal to 5 volt. Okay, so this is the information that you can get it as after you compare with this equation. All right, now for G1, right, here, so we know that G1 is equal to RF over R1, right? So how to get it, this one is based on the circuit, right? So minus and plus. So all is from the inverting circuit. The concept is draw the inverting circuit first. Okay. So this one is RF, this one R1, this one is V1. And of course, you got it is minus V out here, right? So let's say we draw the inverting first. We say this one is V out. However, the voltage here will be negative here. Okay. All right. So for the summing circuit, that means you have two input here, right? V1 and V2 here. So that means you have another input. This one the V2, this one the R2. Okay. So our objective is we want to find all of this value, RF, R1, R2, V1, and V2. And V1 here is equal to V in. Okay, you already decided, right? V2 here is equal to 5 volt. Okay, done. How about RF and R1? You can get it from G1. So G1 you got it is 3.4 equal to RF over R1. So let's choose the value of RF here. Let's choose 34K divided with 10K, right? 34K divided with 10K, so you got it back 3.4. So that means the value of RF you can use is 34K, and for the value R1 you can use the 10K. Okay, done. So how about the R2? R2 is from G2, 1 RF over R2 here. Then R2 is equal to RF, where your RF is 34K. So this R2, the value of R2 is 34K. Okay. Alright. So far, okay. Is it okay so far? It's not the so far. Do you have any question? If I choose 5 as G2 and 1 volt as V2, is it valid? Yes, sure. Muhammad Zami. Wow, Zami manja ni. Alright, so you can choose another. You can choose that one also. For example, you choose G2 is equal to 5 and V2 equal to 1 volt. Yep, you can choose it. But of course, the formula will be here. At here is I write down here, right? Okay. Sorry, this one. Of course, formula will be 5 equal to RF divided with R2. Okay, right? So, and then you need to divide RF divide with 5, okay, in order to get the R2, right? It's okay. Okay, sir, multiple possible answer. Good. And so now for the summing circuit, we already found it R1, RF, R2, V2, V1, and we got it is minus V out here. However, based on the question, you can see that the positive V out here we want. Okay. So what you need to do is you need another inverting. All right. This one and minus and plus. Oh, back to the answer. Multiple possible answer. Yes. Yes. During your test one, yep. You can choose any value that you want. For example, this one, right? You can choose it. Maybe some of you choose 3.4 ohm divided with 1 ohm, right? It's correct. In theoretically, it's correct. But when you go to electronic shop, uh, you can ask, uncle, can you give me 3.4 ohm? And then the uncle will slap you, and then will say that go and learn again. Okay. So there is no resistance 3.4 ohm. Okay. All right. Is it? Is it true? No, I don't think so. Okay. So this one you need the 1K and also 1K. And then this one you will got it is positive. All right. Positive V out here. Okay, right, clear. We need another inverting because we want to achieve positive V out here. That's why we need a V out. All right. So far, okay, clear. Summing. Okay. Any question? No. All right. So let's go to another one. Or you can see the solution in my slide here. Okay. Differential. All right. So I delete this all. Some of your friends are recording this, right? So maybe you can ask the video, right? Okay. Last one is the differential. Okay. What is it? Number 3, right? Okay, differential. Differential. The circuit will be like this one, minus and plus. Right. So you call it back here. Okay. And then you have another resistor here, and we shut to ground. Okay. So now this one is the V out. Alright, so this one is the V1 and also V2, RF, R1, R2, and also R3. Okay, but so what the differential do is compare between two input, only two input. One OM can compare only two input, V1 and V2. Okay, and then this is the step, right? How to get this the formula for this one. However, there are one formula that you can use. V out here is equal to RF divided with R1, V2 minus V1 here. So V2 minus V1 here. Right. In one condition, that means RF must equal to R3 and R1 must equal with R2. That means when you go buy the resistor, right? RF, right? Sorry, the value for this R3 must be equal with this RF. So we can say that this one is RF, and the value for R1 must equal with value R2. So we can say that this one is R1. Okay, so you just need two type of resistor, two value of resistor, RF and R1, in order to use this formula. Okay. If you don't, you choose another value, that means you cannot use this formula. Okay, so let's look example 5.4. Alright, okay. A sensor output a range of 20 to 250 millivolt as varies over its range. Develop signal conditioning so that it becomes 0 to 5 volt. Okay, so now you have the let's say the sensor, right? So we can draw the graph and so on. So the input now is 20, okay, to 5 millivolt, and then you want to make it a 0 until 5 volt here. So 0, 20 to this one is 50. So you want to get this one, and you got it, this one, the V out. All right, so this one is the V in. Okay, so after you do, so you got the equation V out it is equal to 27.74 V in. Okay, let's me. Alright, that's enough. V out equal to 21.74 V in minus 0.435. Okay, now this is the question that you got it from the question. Okay, now what you can do is you can compare with this formula. Okay, so you got it is V out Rf over R1 V2 minus V1. Okay, you can compare this one. However, you need to factorize this one first. Okay, so V out here, you got it is V out equal to 21.74. We time with V in minus 0.435 divided with 21.74 here. Okay, then you will got it 21.74 being minus with and 0.02. This one be out. Then you can compare with the differential equation. Okay, you can compare it. So when you compare it, now you got it is Rf over R1 here, because the differential only need two value of resistor Rf and R1, okay, is equal to 21.74. So now you got it Rf over R1 21.74, right? And you can choose any value that you want. Let's choose the RF 2127. Okay, okay, maybe you have it. So this one is 100K. Okay, so RF we choose it 2174K, and this one is 100K. Done. Okay, all right. So now, then we can compare V2. V2 is equal to V in. Alright, V2 here is equal to V in. Done. And then another one is minus V1. Please take it the minus also. Right, is equal to minus 0.02. Then you got it V1 0.02. Okay, V1 0.02. So this one, the input is 0.02. Okay. Sometimes you got it the value, all right? Sometimes you got it the value minus. Okay, for example, let's say I change this one, all right? I put it is plus here, 0.02. What happen is this one will be plus and this one will be minus, right? Then you got it the minus voltage here at the input. It's That means the minus voltage, it doesn't matter because you can have the voltage, right, in terms of negative voltage, right, going to this point. Okay, do you have any question? Ada apa-apa soalan? Is it clear? Clear? Is it clear? Ada apa-apa soalan? Okay, good. All right, so all right. So, this one also, all right, for this one also, for last before this is minus, right? Okay, minus. All right. Okay, let's say we got it, the equation from the graph is here, right? Okay, from here. Okay, we also can use the summing circuit. So we just compare minus V out, G1 V1 plus G2 V2, because this is only two input here. And then you can compare. Okay, you can compare V1, V in, this one, sum. Okay, so the good thing is you can use the summing circuit also. It will give you the same output with the differential. Okay, now we move to voltage to current converter. Yep, sometimes we use this one, but sometimes we don't use it. It is depending on your application. All right. Voltage to current converter, you can look into that. Just maybe you can go through on a little bit, right? So you can get it current and so on. And this one, same thing about the current to voltage converter. All right, so sometimes we use it, right? Okay. So let's go through the comparator. Okay, the most important thing about for your test one is the comparator. Okay, so comparator is used to compare between two analog voltage of its input terminal. Okay, so normally the comparator, right? So we can use it to make an alarm system. Okay, so we can use the same OM. Okay, so now this OM I always draw minus and plus, right? But the comparator, the symbol, let's take it plus and minus. Okay, so why I draw like this one? Okay, this OM have the 3 pin, right? Okay, here. And then to make it as the comparator, right? So you can have the analog voltage here, for example, VA, analog voltage 1, right? And you have the analog voltage here is VB, okay? So when this voltage, right, VA is more than VB, VA is more than VB here, right? Okay. So what happened is this OM, right, it will have the output here, right? Okay. So this one will be only 1 or 0. If VA more than VB, so the output will be 1. And if the VA less than VB, so the output will be 0. This is the comparator. Okay, all right. Okay, so let's say, okay, this is the concept of the comparator. I will explain is okay. Okay, sometimes we call it, sometimes this one, we call it is V reference, right? V reference. That means the voltage that we want to set the limits, right? Our reference. So if VA is more than V reference, the output will be 1. If VA less than V reference, the output will be 0. Okay? All right. And let's go through this example 5.4. A process control system specifies that temperature and pressure should never exceed 160 degree and 10 kilopascal. Okay, so now you got it. Temperature, and also pressure. That means the temperature should not exceed, okay, should not exceed 160 degree, and the pressure should not exceed 10 kPa. Okay, so that means temperature and pressure should not exceed. That means both cannot exceed. Design an alarm system to detect this condition. Okay, right? Like you have learned on programming class, right? Temperature less than 60 degree, right? Uh, cannot exceed. This one what you have learned in programming class, uh, 10 kPa. Okay, but of course you cannot write this symbol, right? So it needs to be less and equal, less and equal. Okay, yep. So this is the condition for this question. Okay. Design an alarm system to detect this condition using temperature and pressure transducer with transfer function 2.2 millivolt per degree and 0.2 per kPa. Okay. So now we want to design the alarm system. So let's move for first transducer, positive minus. Okay. So for the temperature, the we call it the transfer function millivolt over degree. Okay, then we got it the first output 1. Let's say output 1. Okay, so now the question is what is will be at this one, the V reference here. Okay, so let's say I put it is VT here. Okay, Vt here is, okay, is equal to 160 degree time with 2.2 millivolt over degree. Alright, so 160 degree times 2, you got it 0.352. So why I choose 160 degree? Because I want to achieve this condition. I want to fulfill this condition. Okay, so let's say the input, the reference is 160 degree, right? Okay, so when you have um, the input here is 160 degree, that means your temperature sensor detect 160 degree, right? 160 degree. So that means it's more than 160 degree, right? So you will got it is 1. Okay, all right, okay, right. If that condition go like that, right? So if you got it 180 degree here, okay, it's more than 160 degree, then you got it 1. And if you detect the temperature for 100 degree, that means 100 degree less than 160 degree, so the output will be 0. Okay. But of course, in electronic circuit, you cannot measure on degree, right? 160 degree. So you will be measured in terms of voltage here. That means on this OM, right, at N3 to 4, you need to put the voltage 0.352 volt here. Okay, that represent 160 degree. Okay, all right. So when you got it 100 degree here, you detect the 100 degree here. So the voltage, right, will be converted by this transducer 100 times with 2.2. What you got it? How much you got it? 0.22, right? I'm right. Okay. Betul tak? Betul Betul ataupun tak? Tut, 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 tut. Okay. Alright. So that means the 0.22 volt is less than 0.352, so the output will be 0. Okay. So far, do you have any question? Ada yang tak faham? Do you have any question about this one? How we going to find this P reference is based on the question that said the temperature cannot exceed 160 degree. So that's why we set it, the reference voltage is 160 degree. However, in the real application, so how we going to put degree into the LN 324, which is the what we call it, the circuit, right? So we need to put some voltage here. Okay, right. How about the pressure? Yep, you have another one, right? Another comparator. So this one will be the pressure. So what is the sensitivity or transfer function for pressure, kPa here? Okay, so the pressure that you want to achieve is 10, right? So let me put it here is Vp equal to 10 kPa if time with 0.2 volt over kPa here. Now you got it is 2 volt here, right? Okay, so that's mean in this comparator, the reference need to put 2 volt here. Okay, then you got it, the output is output number 2 here. Okay, all right, 2 volt here. So 2 volt, that means it will represent the 10 kilopascal. Okay, so this is the limits, right? The reference of your for the pressure transducer. So that means if you got it, for example, what we call it, 20 kilopascal here. Okay, kPa here. Then you will convert 20 times 0.2. That means how much is it? 4 volt. Okay. 4 volt. 4 volt is more than 2 volt. Then you will got it 1. Okay. If you detect is 5 kilopascal. Okay. So 5. That means if we got it 1 volt. So 1 volt less than 2 volt. So you will got it is 0. Okay. Alright. Okay. So far so good. Do you have any question? Boleh faham? Clear? Good. All right. Clear. Good. Okay. However, we want to make it an alarm system, right? So this one is only the comparator, right? So how to make the alarm system? We need to achieve on what has been stated in the question. That means temperature and pressure cannot exist, right? Both cannot exist. So what you need after this is you need how to draw. Okay. Alright. So maybe I can delete this one first. Okay. So this both output, we combine it, right? However, we need this device. So we call it, this one is the gate, right? So this one we call it is AND gate, G-A-T-E. Okay, right? Then you got it, the output is alarm. Okay, right. So this alarm will be triggered if this output 1 and output 2 is equal to 1. That means 1, 1, this alarm we got it 1. Okay, AND gate, right? So that means AND gate, right? This one, AND gate. So AND gate, you have learned this one in programming class. So what's the output is depending on 1 and 1 here. That means you multiply here. So 1, 1, you got it 1. Okay. If, for example, the pressure you got it 5 kPa, right? You measure, you got it 5 kPa. That means the output will be 1 volt. It's less than 2 volt. So you will got it is 0. And then temperature you measure, maybe you got it is 200 degree. Okay. And then you got it something else, this one. And output, of course, you got it 1. So your alarm will not be triggered because the temperature has fulfilled, right, has exceed, but the pressure not exceed. Okay, this is what we want to fulfill that question, right? We want to answer the question. Okay, all right. So when we design the alarm circuit, right, the alarm system, that means we will have a one, we call it the truth table. The truth table. So what is the truth table is it will show you the condition, right, or possibility of your alarm system. Okay, right. So for example, output 1 you got it 0 and output 2 you also got it 0. So what happened to your alarm? So 0 times 0 you got it 0. And then output 1 you got it 1, output 2 you got it 0. So 1 times 0 the alarm will not be triggered. Okay. And then maybe output 1 you got it 0 and output 2 you got it 1. So you will got it also 0. And if both you got it 1 and 1, that means the alarm will be triggered 1. Okay. So based on this one, so we know that yep, our alarm system it will trigger if both output 1 and output 2 equal to 1, and it will trigger alarm 1. Okay. All right. If the question said that either, that means either, okay, remember this symbol? What is this symbol? You have learned in programming class. What is this symbol? Oh, yes, good. OR, right? So when you have the OR, that means that is this OR gate, right? This is the OR gate. Okay, this is OR gate. So what is the OR gate is you just plus. So for example, you got it 0, 0, 0 plus 0, 0. And you got it 0, 1, you 0 plus 1, you got it 1. And you got it 1, 1, and of course you get it 2. No? Yep. Or, and also got here only the limit is 1. Okay? So when you got the 1, 1, so we got it 1 here. Okay? So the truth table will be also like this one also 0, 0, 1, 0, 0, 1, and 1, 1. But if we got it a different 0, 0, you plus, you get 0, 1 plus 0, 1, 0 plus 1, 1, 1, 1, 1. Okay, so this is the truth table for the OR gate. Okay, all right, you can go through all the solution here. Okay, all right, so far, okay, do you have any question? No? Okay, you can have multiple transducer here, right? It depending on your application. For example, you want to detect temperature, you want to detect pressure, you want to detect the level, okay, you want to detect and so on. So, and then you can design on your circuit, right? And the most important thing is the AND gate and OR gate, right? You can apply it. Okay. No question? Do you have any question that you want to ask? Is it clear? Okay. So, uh, sign. Okay, you don't have any question. So let me uh, discuss a little bit. Okay. Uh, let's look this one. Okay. All right. The question to be here. Okay. For this question, right? Design signal conditioning circuits that can prove an average voltage V average from four inputs, voltage V1, V2 plus 5 volt minus 5 volt. And then average is being attenuated by 10. So based on this question, right? So what type of signal conditioning circuit that you want to use? We have learned inverting, non-inverting, then what? Voltage follower, summing, and also differential. Okay, that is five basic configuration. All right. So which one that are you going to use?
Summing.
Summing. Okay, good. All right. So it used to produce an average voltage. Good. The answer is summing. Okay. So back on the concept of average voltage. So V average. Okay. We want you to find V1 plus V2 plus 5 minus 5 divided with 4, right? This is the formula to find the average. Okay, and you can divide it in this one, 1 over 4 B1 plus 1 over 4 B2 plus 5 1 over 4 5 minus 1 over 4 5. Okay, or maybe we can write it plus 1 over 4 minus 5. Okay. Alright. So this is the V average. Okay. So you can compare it, right? Minus V average. Sorry. For the summing circuit, V out equal to G1 V1 plus G2 V2 plus G3 V3 plus G4 V4. Okay, then you can compare. Okay, G1 1 over 4, G2. Okay, so G1, let's say 1 over 4. So what is mean G1 RF over R1 equal to 1 over 4. That means your RF equal to 1, your R1 equal to 4. Okay, alright. So same thing with this one. G2 1 over 4 also. Then you got it is RF over R2 1 over 4. That means RF is 1, R2 is equal to 4. Okay. Then you start draw your summing circuit. All is based from the inverting amplifier. Okay, because you got it 4 input here. Okay, so this one RF, right? RF now equal to 1. So this one is 4, this one also 4, this one also 4, this one also 4. So you got it V1, V2, alright? And V3 is equal to 5 volt. So this one is 5 volt. And V4 equal to minus 5. So minus 5 volt. Okay. Then you got it is the output will be minus. Alright. So in order to achieve the output, right, for the positive one, minus and plus, right? So this one we call it positive V out, or is same thing with V average here. So because of this one, minus V out, right? Because we want the positive V out. We want the positive V average, right? Positive V average. So that means we need another inverting. Okay, right? And you can use the 1K and 1K here. You can get the V average here, right? However, the answer said that the average is being attenuated by 10. That means attenuated, that means from the larger voltage, it can be small voltage here, right? So what the value that you're going to use here? How about this one? What is the value? So the gain here is RF. Maybe we can take in minus RF over R1. Right. So you want being attenuated. That means it will multiply with 0.1. Right? Or 1 divided with 10. Okay? Right. So the 1 divided with 10. So minus RF over R1. Right? So you can choose RF 1K and also R1 is 10K. Okay? Right. So 1K and this one is 10K. So it will attenuate. Okay? It will attenuate. Right? So this one you can do 1K and 10K here. Or maybe you need another inverting. For example, you can use 1K, and then you need another inverting. Oh no, you cannot need another inverting because it will be make negative value. Maybe you just need non-inverting, right? Non-inverting, yes, you can. Okay, good. Do you understand? Okay. Do you have any question about this one? Sorry, my screen it's not mounted. I don't know why. Okay, good, good, good. All right. So this is the way, right? So use the summing because you have the 4 input here, right? 4 input here. Here you use summing, and then we need some inputting, right? And because you want to achieve the attenuation, that means you need to use the difference value for the system. Okay, and the last one, yep. Uh, let's look this comparator. Figure 2 show below a liquid mixing system. Mixing tank that have several transducer. You have the pressure transducer, oxygen, temperature, and liquid. Wow, you have 4. Design a system that will be triggered if one of these conditions is detected. So if the level, liquid level exceed 15 cm and tank pressure exceed 20 kPa. Okay, if this one is that mean is exceed, that mean this both is exceed. All right. Okay. And then will be trigger if one of these, or that mean at the end this one you will use the OR gate because it will trigger if one of this condition. Okay. Then when the liquid level exceed 100 degree and oxygen level exceed 23%. Okay, that means if this condition, right? If condition number 1, right, and condition number 2, right, is either one is exceed, so alarm will be triggered. So you can design this one, right? So based on your answer. Okay. All right. I leave it to you because this one it will be an assignment. It's for you. Okay. So and then I have uploaded in the e-learning. Our section is section one. Section one. Okay. SEMM. So please go to SEMM 3242-01. Okay, and then you go to assignment 1 here. So the due date is next week 24 November, right? So you can go inside this one and then you can upload, you can download, sorry, the assignment. Okay, so some of the question have been discussed here, and then you need to do another one. Okay, so this is the previous test one. Okay, for the last semester. All right, so please submit this one in the e-learning by next week. For those who can't access to this e-learning, please let me know because for the test one, you will going to use the e-learning in order to submit your answer script. Okay. All right. I think that's all for today's class. So I will see you again on next week. Okay. Bye bye.